Welcome to another episode of MrLopezClasses.com. This is our diesel engines course, and this is the chapter 10. The chapter 10 is dedicated to lubrication system. We are going to check what happened with the oil, what happened with the path of the oil internally in the block, and how the pressure on the oil is produced, and how the oil is filtered, and where are located the small cavities inside of the block where the oil is passing. This is a very interesting video. In the second episode, I am going to explain the different type of oils, the classification of the oils, why the oils for diesel engines have a different specifications, and what type of detergents are used in those oils. And there is another video clip, wonderful video clip. In the video clip, I am going to explain the procedure to analyze the report of the oil sample when you send the oil sample to the laboratory, and we are going to analyze in that video clip all the possibilities. We are going to check medal by medal found in the report, and we are going to check what happened if I have excessive amount of that medal. Where is located the problem, the possibilities, and what is the solution per each case. It's a big table that we are going to create in the classroom, and I hope that you enjoy that video clip. This is one of the video clips that we are going to bonus video in this course. Okay, we are going to start with the chapter 10 about the lubrication system. Of course, the lubrication system internally in the engine starts with the oil pump. The oil is suctioned from the oil pan by means of the oil pump. The oil pump, right now I am going to explain how the oil pump works and how the oil pump sends it or suction the oil from the oil pump and circulate the oil internally in the block, lubricate crankshaft, camshaft, rocker arms, the head on top, and after that the oil return into the oil pump by gravity. Okay? In other words, the circulation of the oil is in a semi-closed system. We are going to study later in our book of auxiliary systems. We are going to study hydraulic systems, and we are going to try to understand that the secret in a typical hydraulic system is that the pressure is constant. In this system, in the oil on the engine, the pressure is constant until the oil reaches the top of the rocker arms. After that, the oil returns into the oil pan by gravity. It's a semi-closed system. It's closed until this point, and after that, by atmospheric pressure goes down into the oil pump. Right now we are going to check the path of the oil. But now I want to share with you the different videos that I prepared to use in order to explain the process step by step. Okay, the first step is the removal of the oil pan. And this is the oil pump. We are going to remove the oil pump carefully. And immediately you remove the oil pan. Be careful with the gasket. This is very, very important. You have access to the oil pump. That's the oil pump. And this is the strainer or filter. And this is the oil pump. This strainer, this is an important element. Because what happens if this strainer is clogged? The circulation of the oil is not enough, and you have a lack of lubrication, and you have millions of problems internally on the engine. How the strainer, how that filter, that strainer can be clogged? If I replace the oil according with the manufacturer recommendations, and suddenly that strainer is clogged, there are different possibilities. One possibility is that the oil used on that engine is not the recommended oil for that engine. Other possibility is that the owner of that engine used too much additives, and the additives produce too much gel, especially at low temperatures. And those gels are deposited in the oil pans and clogged the strainer. Very common. We are going to study later that situation. Okay, this is the oil pump. And now we are going to try to explain the process, how the oil pump works. This is the explanation about the oil pump. Okay, my friends, this is the oil pump. Correct, this is the strainer. The oil is suctioned over there and enter in the pump. The pump internally have two gears. This is the driver gear on the shaft, the driver gear, and the other one with the dot is the driving gear. Correct. The driver gear. In the other side, the shaft of the driver gear. The shaft of the driver gear have a slot. And this slot, this channel, engage with the shaft of the distributor. In this moment, I am going to explain both scenarios. The gasoline engine, the oil pump for gasoline, and the oil pump for diesel. It's the same. It's the same function, the same operation. Okay, in this particular case, in this particular example, the oil pump engage the shaft of the driver gear have a slot, and the slot enter in the spring on the shaft of the distributor for gasoline engines. You see, in like the picture, like the video, those elements engage one into the other one, and when the distributor is spinning, the oil pump is running and suction oil. And how the distributor is spinning? The distributor is spinning because if you check here, we have a gear, and that gear engage with the gear of the camshaft. The gear of the camshaft. Yes, if you see, okay, those gears engage one with the other one when the camshaft is move the distributor, and the distributor sends the spark. In gasoline engine. In diesel, when the camshaft is moving, the pump engage with this particular case. This is an example. This is a fuel injection pump, a rotary fuel injection pump. In some engines, you can install that pump vertical, and if the pump is vertical, the shaft of the pump, of the fuel injection pump, engage with the driver, with the shaft of the oil pump, and the oil pump suction the oil and circulate the oil internally in the block and the head, and the oil return into the oil pump by gravity. Okay, this is in diesel. In this particular case, this fuel injection pump is vertical and engaged with the shaft of the oil pump. In some cases, the fuel injection pump is horizontal, and the gear of the crankshaft engage with the gear of the camshaft and engage with the gear of the fuel injection pump. Those three gears engage together and work together when the pump is mounted horizontal. In this particular case, it's mounted vertical and engaged with the vertical oil pump. Different ways, but always the gear of the oil pump is moved because the other gears, crankshaft and camshaft, are running together and move that gear, and the oil pump is running. That's clear, my friends? Okay, this is the situation specific in that case. Okay, and now I am going to explain to you the procedure to remove the oil pump. Remove the oil pump is too easy. You need to exactly remove the bolt, and in the other side are located the gears that engage with the crankshaft and camshaft. This is a simple procedure. Immediately you remove the bolts, you can open the oil pump, and you can see both gears located internally. Okay, the driver and driving gear. Okay, both of them, and this is the procedure to remove that oil pump. Okay, how often should be replaced the oil pump? In each overhaul, the oil pump should be replaced. Or if you have problems of low pressure, And for example, you replace the bearings, you replace the gaskets, and the oil pump, the oil pressure continue low oil pressure. Probably the gears on the oil pump have too much play, and the pressure produced for the oil pump is not enough. For that reason, I recommend always in any type of reparation, replace the oil pump. No, I am going to rebuild the engine, but the oil pump looks good. No, my friend, replace the oil pump. It's not expensive. It's one of the elements less expensive in the reparation of the engine. Replace the oil pump always, okay? All right, my friend. Right now we remove the oil pump, and this is the moment. This is the moment to verify. Immediately the oil pump suction the oil and send into the block. Before the oil enter in the block to circulate in the block, the oil pass for the filter, the oil filter, and of course the oil filter is located in the bracket bolted in one side of the block. This is the element that you replace in the service. When you replace the oil, normally you replace the filter, of course, and replace the oil. Okay, in this video, okay, we have the bracket. This is the bracket. We remove the bracket where the dipstick is located in that bracket. Okay, in the same bracket, we bolted the filter, and you have the option to install, because normally in those brackets you have different holes to install oil pressure gauge like this. I recommend, if you are the engineer in a big boat, in a mega yacht, I recommend that install oil pressure gauge on the bracket where the oil filter is located. This is good for you because you enter in the engine room and you can check the oil pressure of the engine easily. Or other engine, they have the oil pressure incorporated in the control box, like the picture that you have on the screen right now. This is good. That's your decision. If you want another oil pressure gauge, I love it. Install that oil pressure gauge in the bracket, because this is the maximum pressure produced on the engine is located in that point. For me, it's a good indicator about the pressure of the oil. Okay, or you can install over there a T and install the oil pressure switch and the oil pressure sensor that right now we are going to talk about those switch and sensor and what is the function. You remember we did the harness in our electrical course, and now we are going to refresh the moment where I install the oil pressure sensor and the oil pressure switch in the engine. Right now it's easy for you because you understand what happened with the movement of the oil. Yes, in that point you can install one T, a T like this, the T that you have exactly, and in each end of the T you install both sensors, the oil pressure sensor and the oil pressure switch. Okay, right now the oil pass through the filter, and after that enter in the block. When the oil enter to circulate in the block, this is the situation. The oil pass through the cavities, and circulate internally. In this moment, exactly the same pass in the plain bearings for the camshaft. The oil enter over there, and you have lubrication in all the plain bearings. Yes, my friends, because the oil, you see, the oil penetrate those holes and produce the film of oil in between the crankshaft or camshaft and the bearing. And this is the pressure that you read in the oil pressure gauge. For that reason, the quality of the bearings should be the appropriated quality. The quality of the bearings should be perfect, and the tolerance in between the bearings and the crankshaft or camshaft should be according with the manufacturer specifications. If not, the oil pressure is not the appropriated. Normally the people say, no, I am going to replace the oil pressure in order to get more pressure. Papi, probably you need to verify your bearings. For that reason, how can I verify the bearings? I need to disassembly the engine. No, not necessary. You can take the oil sample, and with the concentration of different metals in the oil sample, you can analyze the report and you can take a decision. Oh, I found it too much lead, too much zinc. Oh, probably my bearings are out. A little amount of copper. this is a perfect indicator that my bearings are out, and I have additionally low oil pressure. This is an indicator that the babbitt in my bearings are out. This is the babbitt, no? The soft metal, the white metal. Now you understand how important are those holes, because those holes communicate the oil and produce the pressure in the system. Once again, my friend, don't forget, the oil pressure gauge and the temperature gauge are the most important gauge. Those are the gauge that the driver, the captain need check always, all the time, in order to verify the temperature and the pressure. Okay, this is the procedure, and the oil circulate through those holes, different holes, and produce the maximum pressure. There are other elements that allow the pass of oil in order to circulate completely. Those elements are the lifters, the push rods, and the connecting rods, the rocker arms. Let me show to you exactly what happened in that situation. In this particular video, look, the oil from the block of the engine enter in that hole. This is the lifter, and the lifter have a hole on top. If you see that hole on top, the oil penetrate in the side, pass here, and enter in the push rod. The push rod is hollow. Exactly, this is the push rod, and it's hollow. Okay, now the oil pass through the lifter, enter into the push rod, and the oil at the end pass through the rocker arms and lubricate all the rocker arms, and for gravity now go down into the oil pump. This is the path of the oil. Let me show to you what happened internally in the engine when the engine is running. Look, in this moment the engine is running and the lubrication starts here, because the push rod, this is the push rod. Okay, if you see right now, the oil is coming. And the oil penetrate this element, the train of rocker arm. Look at the lubrication, This is a perfect lubrication. The engine is running because the oil is coming from the bottom, lifters, goes up and circulate here, and right now the train is perfect lubricated. My friend, I like this video. This is a perfect explanation about the circulation of the oil. My friend, if you have oil in this area, it's possible that the oil goes here down and penetrate in the combustion chamber. Yes, this is possible. If you don't have those seals. You remember those seals? The blue ones? Those are the seals of the valve guides. And additionally, if you have too much tolerance in between the valve and the valve guide here, in between this and this, the oil penetrates over there and enter in the combustion chamber. For that reason, those seals, the blue ones, are critical seals. We need to replace those seals frequently, because those seals are the element that avoid that oil enter in the combustion chamber. And what is the consequence? You have blue smoke. If you have oil penetrating the combustion chamber, of course, during the combustion, the engine burns the oil and produce a blue smoke. All right, this is the typical consequence. I have this wonderful picture. This is the summary of the explanation that I did. Okay, the oil in the bottom, in the oil pan, you have the oil, and the oil pass through the strainer. This is the strainer. The oil continue in. This is the oil pump. The oil pump that we disassembly a couple of minutes, and the oil continue and penetrate to the crankshaft and camshaft, and penetrate and also pass internally through the connecting rods. The majority of the diesel engine, the connecting rods are hollow, and the oil pass internally. And additionally, there are oil jets, and the oil jets spray the oil in the bottom of the piston. But you remember that the piston have the oil controller rings and the oil return. The oil controller rings and the oil return. And other amount of oil goes through the push rods and lifters, goes out and return in the bottom for gravity. Return for gravity. And here the oil return. This is the explanation about the path of the oil. This is not complicated. The secret is keep those cavities internally, those small holes internally properly lubricated and clean. The only way to do that is replacing the oil periodically according with the manufacturer recommendations, and replacing the oil for the appropriated oil. Now we are going to talk about that. The oil recommended, no, I am going to replace, flush the oil for the most expensive. Be careful. Probably the most expensive oil is not the appropriated oil for that engine. What year is that? Oh, this is an old diesel engine, 1984 or 1973. Oh, it's an old engine. Okay, what type of oil you want? No, I want to use the full synthetic, the new one. No, probably that engine originally, the manufacturer recommended mineral oil. Check the manual. Check the recommendation of the manufacturer and use the appropriated oil. Don't try to, no, because the new one is better for new engines. The new one is better for some specific designs recommended by the manufacturer. Check the manual and use the appropriated oil, and you don't have any problem. Why the appropriated oil is important? Because the seals, the gaskets, the material, you remember, the neoprene, the different material uses for those gaskets are according with the oil. Okay, the gasket, the O-rings, the seals for that engines are for mineral oil. If you put full synthetic oil, you destroy those O-rings, those seals, and you have a lot of leaks, low compression, and the engine finito. Alright? Be careful with that and follow the manufacturer recommendation. There are other elements that work internally in the block with the pressure of the oil. Okay, of course, you remember in the previous small video, the lifter receives the oil in one side and compress the oil, and the oil is pushed through the push rods and lubricate the top of the valves and return for gravity into the oil pan. But there is another element internally in the engines that use the pressure of the oil to work. It's more common in gasoline than diesel. Exactly. The tensor of the timing chain. This is a perfect example. This is the timing chain used in gasoline applications, and this element is the tensor. The tensor is a hydraulic tensor. When the pressure of the oil is the appropriated, that tensor turns and keep this chain properly turns, and the timing is not affected. What happens when this element, the tensor, not extend properly? What happens with the chain when the engine is running? And probably you have a misfiring because the timing is affected. This is typical in gasoline engines, no? Oh, in that car I have a noise in idle in front of the engine. When I accelerate, the noise disappears. That's the tensor on the timing chain. There is another tensor similar to this one for timing belt. It's equal, exactly the same. All right. Those elements should be, the performance of those elements depend of the pressure of the oil, and the pressure of the oil depend of the service on the engine, and depend of the quality of the oil appropriated for that engine. Okay, this is other element commonly used especially in gas engines in order to keep the timing chain tense. Remember, there are diesel engines, small diesel engines with timing chain and those tensors. For example, you remember, I explained in previous episodes, Perkins and Yanmar, they have a small diesel engines for sailboats and generators. Those engines use a tensor for timing chain, and they use timing chain. Yeah, depend of the manufacturer, you have that situation. This is the tensor. This is another example of the tensor. And the procedure to replace the tensor in the class of gasoline, I am going to explain. You compress with your finger and you introduce a pin. The pin is located here. Okay, when you remove the pin, the tensor extends and compress the chain against the gears, the gear of the crankshaft and the gear of the camshaft. This is a vital element. This element is connected with the cavities internally. If you have the block here, for example, this is the block. This element is connected with the cavities and the cavities are connected with the oil pump. Yeah, and the oil enter over there and extend or retract the tensor. Very, very, very common element used in those type of applications. Okay, now we are going to talk about the oil pressure sensor and the oil pressure switch. Okay, and we are going to understand, we are going to refresh. You remember in electricity, I explained the procedure to do the harness for a diesel engine or gasoline engine. And in that episode, I explained in details the procedure to fabricate the harness. Okay, we are going to use one portion of that video in order to understand, in order to refresh where are located the oil pressure sensor, the oil pressure switch, and how those sensors should be installed in the harness, and how the gauge, oil pressure gauge, should be installed in the system. What other situation the engine stops by itself? Yes, when the oil pressure internally goes below 40 psi, the oil pressure. The oil internally in the engine, normally when the engine is running, the pressure is in between 60 and 80 psi. When the pressure is below 35 psi, the majority of the engine stops for emergency, and immediately you have a check engine code, low oil pressure. Alright, now we are going to install in this harness the oil pressure switch. That switch is a normally closed switch. The contacts internally open only when the oil pressure decreases below the limit. Each manufacturer have a different limit. When the oil pressure internally decreases the limit, the contacts in this switch open and the engine stops. Be careful, because some people confuse the oil pressure switch with the oil pressure sensor. The switch is used to interrupt the purple cable and stop the engine. The switch is a switch. It's a normally closed switch that only opens in emergency, when the temperature passes the limit or when the oil pressure decreases the limit. Both switches. Those are the switches to kill the engine, to stop. The sensors, the oil pressure sensor, where is located the oil pressure sensor? Yes, in the bracket where the oil filter is located. In the bracket where the oil filter is located, this is a point where the oil pressure is maximum. In that point, you have one terminal. In that terminal, you can install the sensor. And in other terminal of that bracket, you install the switch. You install the oil pressure switch and the oil pressure sensor in the same bracket, where the oil filter is bolted. In that bracket, you have oil pressure switch and oil pressure sensor. The oil pressure switch is used to kill the engine, and the oil pressure sensor sends the signal for the gauge, for the oil pressure gauge, and send the signal to the computer if the engine is electronic. The sensor sends the signal through the sender and activate the gauge or instrument. The sensor is to send signal for gauge or computer, and the switch is to kill. Now we are ready to install. In this moment the engine is running, and we need to install the oil pressure switch and the coolant temperature switch. Where is located the oil pressure switch? On the bracket where the oil filter is located. We are going to install both of those switches here. This is the purple cable to keep the engine running, fuel transfer pump and solenoid fuel injection pump. Okay, I am going to install my oil pressure switch here, and I am going to install my coolant temperature switch
here, both of them, this is coolant switch, coolant temperature switch, and this is oil pressure switch. Both of them are in series with the purple cable. Okay, this is the procedure to install the switch, and right now we are going to start with the procedure to install oil pressure gauge, temperature gauge, fuel gauge, tachometer. In that case, we are going to use the sensors. In order to connect the gauge, oil pressure gauge, don't forget that when we activate the preheat or ignition switch, I feed an ignition bus bar, purple color. This ignition bus bar is coming from the ignition position in the preheat button or ignition button. That's the preheat. Is other positive bus bar, but the name of that positive bus bar is ignition. Normally, when I wire both, I create an ignition bus bar smaller, and I create a positive bus bar, and I create the negative bus bar. Very important. Remember, in the previous episode in other chapters, when you have different group of batteries, the most important part is connect all the negatives of each group of batteries together, and together with the main negative bus bar on the engine room. And the negative bus bar on the engine room connected to the bonding conductor, and the bonding with the sink. Don't forget, this is important. Connect all the different groups, the negatives together. If not, after that, it's impossible to send signals. Alright. Okay. Now we are going to start to connect the switches. The gauge. Oil pressure gauge, temperature, fuel. All the gauge, as you can see in the diagram that I have right now on the corner of the screen, all the gauge in the back, they have 3 terminals. One terminal for ignition, other terminal for signal, and other terminal, normally the middle one, for ground. 3 terminals: ignition, signal, and ground. All of them. All of the gauge for oil pressure, temperature, and fuel, they have 3 terminals in the back: ignition, ground, and signal. Remember, in order to send the signal to the gauge, we are going to use the sensors. In this particular case, we are going to use oil pressure sensor, and all the ignition positions shall be connected through the ignition bus bar. Normally this cable, the color is purple. And this one connected to the ignition bus bar. And this one connected to the ignition bus bar. Why I connect in this way? Other technicians, they say, okay, I connect this one to this, and I connect from this to this, and from this to this. This is good? Now because you have the gauge connected in series. What happens if the middle one is broken? You don't have ignition signal in any of the gauge, and all the gauge are out. What happens if you don't have power in the first one? The rest are disconnected. It's not a good idea. In this way, what type of connection is that? I create the ignition bus bar, and from each is connected each gauge. This is a parallel connection. What happens if this one is damaged? The other ones are working properly, in parallel. Don't forget, the majority of the people, 90% of the boats, if you check in the console, are connected in series. For that reason, when one gauge is damaged, all the gauges are damaged. That's not good. Connect in parallel. Alright, in parallel, I am going to connect the ignition position. Okay, and this is the oil pressure sensor. All right, the oil pressure sensor normally is bolted on the bracket where the oil filter is located, and normally the oil pressure sensor have two terminals, one terminal for ground and the other terminal to send the signal for the gauge.